Hi guys, today we're going to learn about inscribed angles. An angle, we say that it's inscribed if its vertex is on the circle and its sides contain chords of the circle. So in this case, you can see this beautiful circle, and we say that the angle ABC, meaning this one, is going to be an inscribed angle. So the inscribed angle theorem tells you that if an angle is inscribed in a circle, then the measure of the angle equals 1/2 the measure of the intercepted arc. Meaning in this situation, when we have this, you know that angle B, it's going to be 1/2 the measure of the arc over here. That arc is going to be the measure that comes from here to here. Okay, so we say that angle ABC intercepts the arc AC. Okay, if the measure of the arc AC is equal to 100, we say that the angle ABC is going to be equal to 1/2. Okay, here we are using the theorem directly. Now, if you have that the measure of the angle ABC is 70, then you know that the measure of the arc AC is going to be twice as much, therefore you know that it's going to be 140. Now, let's look at this corollary. If two inscribed angles of a circle, okay, or congruent circles intercept congruent arcs or the same arc, then we know that the angles are going to be congruent. Okay, let's put some examples here so you can see that it's pretty simple, but if you see it, it's easier. Okay, so angle 1, we say that angle 1, let's look at angle 1, is this one. Okay, so the arc that you're looking here is CD. Okay, so we say that it intercepts the arc CD. In the same way that we say that angle 2, oh my goodness, look at that. They are intercepting, can they intercept the same arc? And the answer is yes. What we can conclude from these two angles is that, wow, they are congruent. Okay, angle 1 is congruent to angle 2. Are we okay with that? So you have this, isn't that nice? Now let's move on to another situation that you might encounter. Angle 3, which is this guy, we say that intercepts the arc AB. Okay, so angle 4, we say that it intercepts the arc CD. Okay, so since the measure of the arc AB and the measure of the arc CD, they are equal, meaning basically this, okay, the opening, the arcs are the same. Okay, please note that this is different from the arc length, okay, it's the opening. Okay, they are the same, therefore you know that these two are also the same. Okay, meaning angle 3 is congruent to angle 4. Okay, and it's the opening, it's not exactly the arc length. Okay, so please make sure that you are aware of that. Okay, so if this is 80 degrees, this is also 80 degrees. Okay, so that's what you have in this situation. Okay, for this one, and of course you know that 4 is going to be 40 and 3 is going to be 40. Okay, so that's what you have. If an inscribed angle, and let me write it down for you so you have it here, 40, 40. Okay, so if an inscribed angle of a circle intercepts a semicircle, then the angle is a right angle. Okay, so this one, you know that ideally the center is here. Okay, so this is a diameter, okay, and it's cutting the circle in half, so therefore where is the right angle? Well, this one. Okay, that's going to be your right angle. The next corollary that you have here, it tells you that the opposite angles of a quadrilateral inscribed in a circle are supplementary. What this tells you is that this guy, this angle, is the supplement of this one. Okay, what's the supplement? That they add to 180. So you're going to tell me, hey, so and they are different, right? So let me just put it different. So you're going to tell me, hey, these two are also supplementary. Yes, they are. Okay, so that's for the next corollary. And the last theorem that we have for today is going to be that the measure of an angle formed by a tangent and a chord is half the measure of the intercepted arc. Meaning that you have here the angle C, what's the angle C? It's this one in this case. You know that the angle C is going to be half of the measure of the arc BDC, okay? So BDC is going to be all this arc. I'm just going to do it outside so you truly understand the notation, okay? So the arc outside, okay? So you know that this arc, okay? So it's going to be half that arc. Everybody with me? Okay, so you have another situation here. Maybe you have this angle, okay? So that one, what's going to be the arc that it's intercepted by this one? It's going to be the same, BDC, okay? Which, if you follow, is going to be this arc over here, okay? So that's going to be the intercepted arc for this situation. For example number 1, what you need to do is name an inscribed angle. So you have this situation over here, so what can you tell me? Is this the inscribed angle? No, absolutely not. That's a central angle. So this guy is going to be the inscribed angle. We name it angle A. You can also name it angle BAC, and that would be correct. For example number 2, what you need to do here is you need to name an arc intercept by the angle BAC. So you do know that the arc that it's intercepted by BAC is going to be this arc that you have over here, okay? So this is going to be the arc BC, okay? For number 3, what we have here is that if angle BPC, okay, so BPC is 42, which we have labeled, we need to find the measure of angle BAC, okay? So from the theorem before, we can say that this is going to be half 42, meaning you know that this measure is going to be 42 divided by 2, which you know that this is going to be 21 degrees. For example number 4, what we have is we need to find x. Where is x? X is here. Even though it doesn't have a degree over there, I know that that measure is going to be in degrees, okay? There's no question about it. It's indicating an angle. Okay, so here what we have is that this arc is 100 degrees. Oh, it doesn't have the 100. You do know that this is referring to an arc. There's no other thing that would be 100, okay? Especially in this situation. So I know that this arc is 100, and I do know that this is a semicircle, okay? Because this is the diameter, therefore this is a semicircle. What's the measure of the arc of the semicircle? You know that it's 180. Okay, if this opening over here is 180 and this is 100, what's the remaining part here? You know that this part is going to be 80 degrees, okay? And it's basically from here to here, okay? From L to J, okay? So you know that that's 80 degrees, okay? If that's 80 degrees, if that arc is 80 degrees, what's going to be your x? X, you know that it's going to be half of the 80. Therefore, you do know that x is going to be 40 degrees. And that's pretty much it for this example. Now, for example number 5, what we have is that the segment RS, which is where? Okay, so you know that it's here. Okay, RS, it's a diameter. And TU are diameters, which we cannot suspect because they look like diameters. And they are diameters of the circle A. We want to find the angle B. Where's B? Okay, B, R, T. And you're going to tell me, oh my goodness, how in the world I'm going to find that? Well, let's see what information we can get. And the other measure. Okay, so I have this is 120. Okay, if that's 120, what do you have? Well, 126, excuse me. This is 54. I will go with that. So if that's 54, you do know that this is going to be 126 degrees and this is going to be 54 degrees, okay? So with that being said, you're like, okay, if this is 54 degrees, I know that this opening here is 54, okay? So now the question is, what do you think that it's going to be this angle over here? Well, what I can tell you is from a previous theorem from yesterday about the tangents, okay, you do know that this is 90, okay? If this is 90 and this comes from the, please note that this angle that I have here comes from the tangent. What are you going to do here? Well, that's the tangent. What's the deal here? you have that this angle that you have over here is going to be half of 54, this one over here. Why? Using the theorem that we saw at the end of previous page, okay? So this one is going to be half 54. So I know that the measure of angle B RT is going to be 54 divided by 2, which you know that it's 27 degrees. Now I know that this is 27 degrees. I know that the full opening is 90, so how can we find the measure of the angle TRS? Because TRS is going to be the remaining piece, okay, of this opening. So it's going to be 90 minus 27, which you do know that it's going to be 63 degrees, and that's pretty much it, okay? So as you can see, I'm using the theorem that I have on the other page, okay? So for example number 6, what I have over here is that I have this beautiful circle that it's centered at A. They tell you that PQ, where's P? PQ, okay, so this part, okay, they tell you that that part is going to be congruent to RS, okay, so this part, these two parts are going to be congruent, okay, which is pretty convenient. You know that angle 1, okay, it's going to be, which is this one from here to here, is 38 degrees, okay, and you know that the measure of the arc QR, where is it, QR over here, is going to be 28, okay. Please note that that 28 is if you have a line here and here, that would be the same angle, okay. So what are we going to do? Okay, so you're going to tell me, hey, isn't the whole thing here a semicircle? And I'm going to tell you, hey, yeah. Okay, so since we know that this and this are congruent, you know that it's going to be, this is going to be 180 minus 28, okay? So you have that that's going to be what's going to be that one? It's going to be 152. Okay, the remaining part, and you are going to divide it by 2. Okay, so 152 divided by 2, you know that that's going to be 76 here and 76 here. Okay, so what I did here is I took out 180 because I know that from here to here it's a semicircle. Okay, I subtract 28 and I got that this is 152, right? And then I divided by 2. Okay, so 152 divided by 2, I know that that is my 76 that I have over here. Okay, so from that I know that angle T, where's angle T? Well, angle T, I cannot get a lot of information from that yet. What else do you know? Okay, I have this, that, what else? I have that this is 38. Okay, what I can tell you here is that this angle that I have over here, this is going to be 90. Okay, hopefully you see it. Then you have 90, 38, so angle 2 is going to be 52. Okay, so let me start researching here. 52. What's going to be angle 3? So angle 3, it's going to be, what do you think? It's going to be 76 divided by 2, you know that that's going to be 38. Okay, similarly with angle 4, you know that that's 38 because you are going to divide this one by 2, so you have that this is 38, this is 38. Okay, so the last question here, well, what's angle T? That one, oh, we already have it. We have that it's 90, and then the measure of the arc PQ, okay, we already know that it's going to be, what's the angle? Oh no, PQ, oh yeah, PQ, the measure of the arc PQ was going to be that one. It's going to be 76, right? And that's pretty much what we have for this problem. Okay, for example number 7, what we have is you have a circle center at Z. Okay, please note that the segment AB, which is this one, is parallel to the segment DC. Okay, so we have that the measure of the arc BC, which is from here to here, okay, so that one is going to be 94 degrees, okay? The measure of the angle AZB, which is this guy that you have over here, that is going to be 104. What this tells you is that the measure from here, from this arc that you have over here to here, that's 104, okay? In addition, since you know that these two are parallels, you know that the distance between this guy and this guy should be the same. Therefore, the measure from the arc from here to here, AD, is going to be also 94, okay? So with that being said, you can conclude that the arc from this part is going to be the remaining, which is going to be 68, okay? This needs to add to 360, okay? So we have a lot of information from the arcs. Let's complete the arcs, okay, if we can, okay? So you do have that this is 104 degrees, okay? Then you have that the measure of the angle BAC is going to be this angle that you have here, which is going to be half of 94, okay, because it's an inscribed angle. Therefore 94 divided by 2, you know that that's going to be 47 degrees. Also, you do know that angle ADB, which is this one, it's inscribed, okay, and this one is related and intercepted, okay? It's the arc, this arc AB is intercepted by that angle that we're talking about here. So it's going to be 104 divided by 2, which is 52, okay? Then we have the measure of the arc AD, which we already have labeled as 94. Then we have the measure of the arc, let's see, D, which is 68. We already have it labeled. And let's see, measure of the angle DAC, which is this opening that you have over here. That one has a relation with 68. We know that it's going to be half of 68. Therefore, that guy is going to be 34 degrees. And last but not least, we have the measure of the angle. What's that? Where's the E? EB, okay? So we're asking for this guy. That one, what are you going to do with that guy? Okay, so that one, what we have here is pretty interesting, AEB. Okay, what do you have here? Well, this one is not a central angle. Are we okay with that? That one, you do know what information from, to get the 86. So I can tell you that this guy, okay, because it's inscribed to this one is 47, in the same way that this one is 47, okay? So this guy is going to be 87 times 2 is 94, 180 minus 94, because this, the addition of the interior angles of the triangles is equal to 180, so I'm going to do 180 minus 94. That's going to be 86. So this guy is 86. Since I know my theorems from previous information, and I'm sorry for my handwriting here, this is going to be 86 as well, because vertical angles, they are congruent. So that's going to be an 86 degrees, okay? So moving on, so as you can see here, we made use of really old theorems like the vertical angles are congruent, okay? So here you have a beautiful quadrilateral QRST. It is inscribed in the circle center C. Okay, so if I know that the measure of angle T, which is this guy, is 95 degrees, okay, and I know that the measure of angle S is going to be 100 degrees, okay, they are asking you, hey, I want to find this angle and this angle. What are you going to do? Well, the beautiful thing is that you have a theorem that tells you that opposite angles are going to be supplementary, meaning this is the supplement of this. So I know that the measure of angle S plus the measure of angle Q, they should be equal to 180, okay, because they are opposite angles, interior angles. Okay, so I do know that S is 100, so I know that measure of angle Q is going to be equal to 180 minus 100, which you know that that's 80 degrees. Okay, in the same way, so this one, check. Okay, so now I know that these two, they are also supplementary. So you know that measure of angle T plus measure of angle R, that's also equal to 180. So what we're looking for in this case is measure of angle R. Okay, so measure of angle R, you know that it's going to be 180 minus 95. Okay, so this is going to give you the beautiful number of what? 85 degrees. Okay, so you do have two things. Okay, so thus, what do you have? Measure of angle Q is equal to 80 degrees. And you have that measure of angle, what was the other one? R is equal to 85 degrees. Okay, so those are your new things. Okay, last but not least, you have that in the circle with center at Q. Please note that this is the center. Given that AC, where's AC, is a diameter. Okay, so this is a diameter. You know that the measure of the arc CD, which is from here to here, that's 68 degrees. Okay, and measure of angle BE. Okay, what's going to be BE? Oh, you're going to tell me, hey, that one is a little bit funky. Yes, honestly, yes. That one, I would call it BE here. Okay, how do I know that it's, you're going to tell me, hey, how do you know that it's that side of BE? I told you that back in the day, when you have only two letters, it's a minor arc. So if I pick BE, this side is going to be a major arc. Instead, this one that I pick, and it's up to here, right? I don't know why I didn't draw the full arc, but so you have that this is a minor arc. Okay, so you know that it's 96. How do I know that it's a minor arc? First, two letters, and also this is less than 180. Okay, so there's too many red flags there. Well, green flags, let's call it. Okay, so this is 96, this is 68. So let's see what we have. Measure of angle ABC. That angle, okay, from the properties that we have here, we do know, because this is a chord, okay, and BA is a chord, given that AC is a chord. Okay, so this is a diameter. I know that this is a 90-degree angle. Okay, so you know the angle ABC is 90. Okay, then you have that angle BDE, which is over here. Okay, what's going to be the deal here? Okay, so this one, it has to do with this arc, right? The arc BE. So it's going to be half of the arc BE. Okay, and what's half of 96? You do know that that's going to be 48 degrees. Let's move on to measure of angle CED. Okay, so this one, what's the deal here? Well, you know that this is an inscribed angle. Okay, so it's going to be half 68, which you know that it's 34 degrees. And last but not least, you know that the measure of the arc, where is it? AD. What's going to be that measure? That one, okay. What are you going to do for that? And it's A, right? D. Okay, so it kind of intersects here. Pretty interesting. What are we going to do to find that one? So we do know that basically AC is a diameter, right? Okay, so we know that this opening that we have over here, okay, is the one that we're looking for, the following thing. Okay, so what I can do there is, I know that this, where's my semicircle? Okay, so I do know that this is a full opening, right? Okay, so I can find ED, okay, pretty easy. 180 minus 96, but hey, I saw something more powerful. This is a semicircle. Do you agree with that? And I want this piece of the semicircle. So it's going to be 180 minus, okay, and this one, I'm just going to write it there, 180 minus 68. That's going to be equal to your beautiful value that it's 112 degrees. And that's it, okay? Hopefully you see that this is one semicircle here and another one, okay? First I tried this one, it didn't work, and then I was like, oh, the full thing, it has to do with 68, okay? So hopefully you find this video helpful. I'll see you later. Bye.